fellow learners. Today we are diving into the world of Langchain agents, focused specifically on SQL agents. We will be exploring how these SQL agents can provide a more flexible way to interact with SQL database when compared to SQL chains. Throughout this video, we will not only explain these concepts clearly, but also dive into the code examples to see them in action. So let's get started. So let's first see the agenda of this tutorial, what we are going to achieve. So in this tutorial, first we are going to implement a SQL chain. So we will utilize a database where there are a number of tables present in a single database. So the size of the tables in the database vary, and also the total number of tables would be around 11 tables in the database. And after this, after doing implementation of SQL chains, we will basically try to find out what are their drawbacks, what are their limitations of these SQL chains, and we will look for the potential solutions. And in the third and final step, we will basically introduce SQL agents and look for how these basically SQL agents solves the problem or limitations that we have seen with the SQL chain. So this is quite our agenda that we are going to follow in this tutorial. For either of SQL chain or SQL agent, there are primarily three major steps. The first step is to convert user's question or query into the SQL query. The second step is to fetch the data from SQL database by utilizing the generated SQL query from the language model. In the third and final step, it uses the fetch data from the SQL database and user's question and pass it to the language model and get the answer from it, and basically finally deliver it to the user. So to get this done, we are going to follow a few steps in this notebook. So let's first write down those steps. In the first step, we are going to import the data. So basically the data is Chinook data, Chinook SQL database. In the second step, we are going to initialize a language model, which is basically GPT 3.5 turbo model. In the third step, we will initialize a SQL database chain using Langchain. And in the fourth and final step, we are going to create a SQL agent using Langchain and see how this SQL agent is beneficial over chain when we are interacting with the SQL database. So to import SQL database into our this notebook, we are first going to import two classes. The first one is connect from SQLite 3 library, and the second one is SQL database from Langchain community.utilities. So the first one, connect class, we can use this to run any SQL query and fetch the results from this SQL database directly. And this SQL database class, we are going to utilize it to get the complete database and the schema of the database, and then utilize this database to pass it into Langchain chains and Langchain agents. So we will just run this cell, and if you see in the next cell, I have used from URI function from SQL database to basically import this Chinook.db database, and also pass this sample rows in table info argument to see and to make it clear how many rows that we need to see in the table info. And in the next line, I have just printed out how many total tables are there using db.getUsableTableNames function, and see what are the different tables that are available in this database. So if we run this cell, we can see there are total of 11 tables. The table names are like album, artist, customer. Those are the different tables that we are having. We can also get the table schema and 3 rows that are present in the different tables in this database using this db.tableInfo. So if you see, after running this cell, we can see for the album table, this is the table description. Like there are 3 different columns: album ID, title, and artist ID. It has also given like album ID is the primary key, artist ID is the foreign key, and it has also shown us three rows from it. So like the first row, if you see, is the album ID is 1, title is For Those About to Rock We Salute You, and the artist ID is also 1. Similarly, it has also printed out for all the rest of the 10 tables its schema and also the three rows from the table. Next thing is like we are also going to see what is the use of this connect uh, class from this SQL3 library. So using this connect class, we can basically fetch the data from this SQL database using SQL queries. So let's first create a connection. So to create a connection, we need to pass the path of the SQL database. So this is the path. We will directly utilizing this. I will write it down over here, and this will create our connection. Once we get the connection, we can create a cursor to run any SQL query. So just we need to use execute function from this connection and write down any query that we want. So we can write down any query from these tables. So let's we are going to use this album table, and let's see if we want to see what are the number of distinct album IDs are present in the album table. So I will just now write down a simple query. Select you can say count. We need to get count of this total number of album IDs, and we also need to see if they are distinct or not. So we will pass this distinct function also, and then pass this album ID column directly over here like this, and then we need to pass this from which table we need to fetch this data. So we'll pass this album table name over here. Once we have written this SQL query, we can directly run this cursor, and using fetch all function from this cursor, we can get what it has fetched from this SQL query. So I will just write it down, this cursor dot fetch all function over here, and you can see this has given us 347 total number of distinct album IDs are present in this album table. Now we have fetched the data, and we kind of know how our database really looks like. We also run this SQL query to know that we can get the data and verify it using this SQL query. The next part is we are going to import this language model. So for the language model part, we are going to utilize GPT 3.5 Turbo model. For importing the language model, we are going to first import three libraries over here. The first one is get OpenAI callback. This basically class we are going to use to get the cost that is being utilized by the calling a single time language model, and also the number of tokens that has been used to generate the output in single call to language model. The next one is chat OpenAI. So this is basically our language model. We are going to utilize this class and pass different functions, different arguments like model, temperature, and other keys arguments, and get the language model. Third one is simple OS. So we are going to use this OS as we have saved our API key in basically our environment as our environment variable. So we will run this cell, and the next is like we will call this chat OpenAI class. We will create object of it and pass these three arguments to it. Model is GPT 3.5 Turbo model. Temperature is 0, so that there can be minimal basically randomness. And third one is OpenAI API key. I have fetched this OpenAI API key from my environment variable, so that I need not to write it every time. So I will run this cell. Now once this cell is being run, we have now our language model. We can basically print this language model. You can see it is basically shown us over here the basically different arguments that we have passed: temperature, OpenAI API key, and basically the model. Now we have our data and we have our language model. So next, jump directly into the chain and agents using Langchain. So for the chain part, we are going to utilize this SQL database chain from the Langchain experimental. We will run this cell. Now we are having this SQL database chain from it. From the SQL database chain, we are going to pass two different main things. One is basically the language model that we have got from this GPT 3.5 turbo model from OpenAI. The second one is a database. We have seen this. We have got it from SQL database class using SQL database from URI. We got this database. It basically has around 11 tables in total, and also it has a schema for all the tables. We will also keep verbose equals to true so that we can see what are the intermediate steps that this basically chain follows. So we will run this cell also. Now in the next part, I will show you how this basically chain performs when there are multiple tables in a database. So in this database, as we have seen, there are a total of 11 tables. Okay, so I will first run this a simple query. So like which countries customer spend the most. So if you see in the database, there is a table named customer also, and there is different other you can say the tables also. So we will run this simple query over here and see how this model performs. This basically chain performs. I have used get OpenAI callback to print out how many tokens it has utilized and also the number, basically the cost that it has, that the cost associated with this particular call. So let's run this cell. So now you can see the first step that it has followed is it has converted this user's question into the SQL query. It has basically utilized two different tables over here. The first one is customer table and second one is invoice table to get the spending from the customers from different countries. For the country part, it basically used a customer table, and for the spending part, it basically utilized this invoice tables. So it has created this query and then order by it by total spending, and basically used in descending order and fetch the topmost result and fetch the data like the USA is the country which has spent most. It has spent for around of $523. So this is the result, final result from the language model. The country whose customer spent the most is USA with a total amount spent of $523, $523.06. And as we have used this get OpenAI callback, we can see that total prompts, total tokens that has been used over here is 4,884. The prompt token that has been passed to language model is 4810. It has only generated this 74 tokens from it, and there were total of two requests was passed to the language model. So the one request is to convert this user's question into the SQL query, and the second request is basically to get the final answer utilizing this SQL result and user's query. And there is total cost of around $0.007 dollars. So this we can get from OpenAI callback. And now I will run a different query and provide you more insight how does this work, and will it able to give the result to this query also. So apart from asking which countries customers spent the most, I have also asked it list the total sales per country. Okay, so I will run this cell and see how it is performing. So if you see in the final result, it has given like the country whose customer spent the most is USA with a total sales of $523.06. If you see this result and the result from the previous query, this is same. So like it is able to give the answer to the second question in the query, but it is not giving result to the first question over here. Okay, so this is one of the problem over here. And if you see, it has utilized around same number of tokens. It is around 4898 tokens. It can it has a little bit increased because the input query is little bit longer. So that's why it has used a little bit more tokens over here. But what is the problem over here? Like in SQL database chain, the number of or the sequence in the database chain is fixed. So if we see the template that has been used by this SQL database chain, we can print this and we can see it has written like you are a SQLite expert given an input question. First create a syntactically correct SQLite query to run. Then look at the result of the query and return the answer to the input question. So the steps are fixed and the steps are as follows. It will see the user's question, convert it into the SQL query, fetch the result from the SQL database, and then finally provide the summarized result. So there is no place for modification or thinking about it, what basically the user wants from it. And also, like we need to pass the whole table info, basically the all the 11 tables schema to it also, because it doesn't know which tables it needs to process. It can only know when we are going to pass all the tables to it. So these are the problems associated with this SQL database chain. One another problem is like it doesn't recover from error. So let's say if there is an error in creating SQL query and it has created a wrong query and then passed it to fetch the database, and there pop-ups an error, it will not able to recover from it. So here comes the SQL agent to the rescue. So how does SQL agents give us more advantage over using SQL chain when we are interacting with SQL database? So there are three major advantages of using SQL agents. These are the three major advantages. So if you see, for the SQL chains, it needs to be passed whole table info of all the tables present in the database, such that it get to know which table it needs to utilize according to the user's query. But in SQL agents, it will only retrieve the schema of the relevant tables according to the user's query. It will not require to get schema of all the 11 tables from the database that we have seen. It will only fetch the schema of the tables which are required to pass according to the user's query. So as we have seen in the last question, so like it requires two tables basically. The first one is customer and second one is invoice. It will only fetch the schema for these two tables only. So it will basically save us few tokens for us. So as you can also think, if the number of tables are higher and higher in the database, it will save us a lot of tokens as we only need to retrieve the few tables which are required as per the user's query. The second one is it can also recover from the error. So basically what does agent do? It will basically generate a query and see if there is any error and then trace back it and regenerate the query and basically find out. So let's say it has generated a query where the table name is customer with C capital, and it has generated a query with table name where is C is in the small letters. So then it will find out what is the table schema and what are the different table names available in the database, and it will again generate the query with the correct table name. So this way it can recover from the errors also. And the third one is the SQL chain are basically having the fixed instructions to it. They're basically the instructions that are given to it are fixed, like you need to generate SQL query from the user's question, then fetch the result from the database, and then finally generate the final answer to the user. But when we are using the agents, it basically utilizes different tools and then think it out and reason it out which tool it needs to be used, and then recover if there is any errors also. And in this way it is more kind of a dynamically answering agent. It is not kind of a fixed chain that we have seen earlier. So to showcase these three advantages of SQL agents over SQL chains, we are going to use create SQL agent from Langchain library. So for this purpose, we are going to first import two classes. The first one is create SQL agent and the second one is agent types. We will run this cell. Create SQL agent, you get to know from its name only that it is a agent. And the agent type is basically a different topic that we are going to discuss is in some another video. But on high level, the different agent types are being used for different purposes. So let's say I'm using SQL agent. So I will be most probably using OpenAI tools as agent type because it has four different kinds of tools available with this agent type, like list down all the table names, check for the query checker, and then schema, find out the table schema also. Different types of tools are available. If I want to basically merge a number of tools and reason it and then find out the best tool and then answer it accordingly, I will most probably use zero sort react description agent type. So there are different agent types available. They are being used for different purposes. The main difference is like they are having different prompts with it, and also they might differ in how many tools that they are having. Can another tool be added on top of the already having tool in this particular agent types, and so other differences are there. So we will be discussing this different agent types available in Langchain in some another video. So as we are now having this create SQL agent, we will get this create SQL agent and create an agent executor. We need to pass a few things, few parameters to it. First one is language model. Second one is database, as you already know. Third one is agent type, which I have already told you. So for this SQL agent type of agent, we are going to use OpenAI tools. If you see its description, there are other tools are also available like tool calling, OpenAI tools, OpenAI functions, and zero sort React descriptions. So these are the different tools available. The fourth parameter that I am going to use is verbose. So I am also going to use true over here also to get what are different intermediate steps that this particular agent is basically using. The last parameter that I am going to use is stream runnable equals to false. So if I am going, so basically by default this stream runnable parameter is true mostly in this particular you can say this create SQL agent. So if we are having this stream runnable as true, we cannot get the cost and the number of tokens from OpenAI when we are basically passing our user's query to it. So for that purpose, we need to pass stream runnable equals to false over here. So we will run this cell, and next thing is we will basically pass the same user's query to user's query that we have passed it in the previous chain, SQL database chain, and see how does this agent basically react with this particular user's query. So the first user's query is which countries customer spent the most, and second user's query is on top of this question which countries customer spent the most. I also want it to list down the total sales per country for all the countries. So we will first run this first query and see how does this agent performs. So if you see for the agent part, it is basically invoking different tools over here. The first tool is so the first tool that it is using is SQL DB list table. So what does this tool will do? It will basically list down all the tables from the database, just the name of all those tables. So if you see over here in the pink color, these are the tables available in the database. Now it will think again, and according to the user's query, it will invoke a different tool, which is basically SQL DB schema, and find out only those table names which are required to run this particular user's query. It has basically fetched three different tables over here: customer, invoice, and invoice line. So and basically fetch the schema for all these three tables over here. Now it has basically this you can say the important tables schema with it. Now it will generate a query from these table schema. So the third tool that it is invoking is SQL DB query over here. So it has created this query for this particular user's question. And after this, you can see this is the query. You can see in better formatted way, and then fetch the result from the SQL database. So if you see, this is the result, which is exactly same as we have seen in the SQL database chain, and it has given the result. Final result is like customer from the USA spent the most with a total amount of $523.06. Now you can notice one thing more over here, like the total tokens that it has used is 4791. So the total prompt tokens that it has used is 4482, and the completion token is 309, and the total number of requests that it has passed is 4 times. So it has called the LLM 4 times. So the first time it called LLM and think it of like what it needs to do. So it has basically got to know that it needs to get all the table name. So it ran this SQL DB list tables. Second time it ran and it basically called this SQL DB schema. And third time it ran and it think of it like it needs to run this SQL DB query. And in the fourth and final time, it has generated the final answer for the user. So this way it has called LLM 4 times, which is 2 times more than the chain. But even after running this 4 times, you can see it has utilized only 4791 tokens. And when we were seeing this chain, it has utilized 4884 tokens. So it is around 100 tokens less, or you can say around 92, 93 tokens less. The thing is like if you see the prompt tokens over here, it has in the chain it was using 4810 tokens, prompt tokens, but in this agent, even after running to LLM for 4 times, it has only utilized 4482 tokens. So you can see how does this gives us benefit over chain by utilizing less number of tokens, even running for more number of calling LLM more number of times than a chain. So this way you can see one of the advantage of SQL agent over SQL chain. Now we will run the second query over here. So on top of getting to know which countries customer spent the most, we would also like to know the sales of all the countries. So basically sales per country. So we will run this cell and see how does this agent gives us the result. As we have seen in case of chain, it was not able to give the answer to the first question. It was only giving the answer to the second question, like which country's customer spent the most. So let's see in the final output. Now you can see our agent has listed down all the countries sales. So you can see all the countries from USA till Belgium, and it has also summarized the final result and given the sales for top 5 countries. And the final result is like the total sales per country are as follows, this for the top 5 countries. And like it has finally given us like therefore customer from the USA spent the most in the sales, most in total sales. So you can see it is in this type of agent in this Langchain, the things are the process is not fixed. It thought of as per the query, like it also needs to list down total sales per country and then find out which country's customer spent the most. So instead of directly getting the total topmost country with the sales, it has basically used this query, which is a little bit different from the previous query, as it is outputting 2 different columns over here, like select billing country as country and sum total as total sales. And then after getting the output from fetching the output from the database, it basically use the output and get to know which countries people have spent the most. So this way you can see in the agent case it is not fixed, it is kind of dynamic nature over here. And even if you see, even after getting answer to the second question also, like list the total sales per country, still the prompt tokens 4645 is lesser than the prompt tokens that were used over here. It was like 4825. And if you see the total number of tokens like 4883, it is kind of still same to the total tokens like it has used like 4892. Still it is 510 tokens are lesser than the chain in the case of chain. And even it has given us the more better results with the sales of different countries, and then finding out which countries people have spent the most. So this way we can see the second benefit of using agents over the chain. Now I will show you what this agent executor have. And like you can see, it has different messages which basically having the prompt with it, and also the different tools in it. So looking into this output is quite difficult, so I will provide you a more formatted output. So if you see, the prompt used over here for this agent is a little bit different from the prompt that has been passed to chain. So like in this case the things are not fixed. It is first given instruction like you are an agent designed to interact with SQL database, but after this it basically asks the AI to see told it like I should look at the tables in the database to see what I can query. Then I should query the schema of the most relevant tables. So in this way it is quite different from the prompt used in the chain, and it is more of dynamic nature. And I was also talking about different tools that it was using. So I will show you also the different tools that it was using. So the tool names are like SQL DB query, SQL DB schema, SQL DB list tables, SQL DB query checker. So in by using these tools, these agents are mostly dynamic, and basically reason it out dynamically and think it of which tool it needs to call. Now this was the second benefit of using SQL agent. For the third benefit, like third advantage, if SQL agent can recover from error or not, I'm going to utilize a different agent type over here. So the different agent type is zero shot react description, which is not quite useful in case of SQL agent, because the prompt is kind of little bit different, which is being used for different purpose. But to showcase you how agents can recover from error, I will utilize this. So I will run this cell, and I now have React agent executor. Now I will run the same question. So like which countries customer spent the most, and see how does this perform over here. So if you see, this is first. So the first step over here in this React agent executor, instead of listing down all the tables, it has basically created a query like select country sum amount as total spent from customer. So if you see, the customers is a different table name, and the actual table name is basically the customer, where C is the capital and there is no S in the last. So it come up with an error. If you see over here, this is the error, like background on this error at. So now the agent is thinking like I need to check the list of the tables in the database to see if the customer table exists. So after that, it ran different tool or different function to like SQL DB list tables. So by using this, now it got to know the in the database the table name is different, which is like a customer, not the customers. So on the basis of that, it has basically used this schema, and based on that, it fetched the data from the database, and now finally it got to know what is the total spending from the USA, the country USA, and also like which country spend the most by using this query, SQL query over here. And the answer is same, like USA has spent the most of around $523.06. Okay, great. So we came up a long way in this video. We first imported the data, SQL database, then initialized a language model, GPT 3.5 turbo model, then used SQL database chain from Langchain and seen how chains perform in case of multiple tables present in the SQL database. And finally, looked into SQL agent provided by Langchain and seen how these SQL agents can benefit over SQL chains when interacting with SQL database. So you can utilize these SQL agents as per your need and see does it gives you any benefit over using SQL chains. In the next videos, we are going to see different basically implementations of these SQL agents. We will also see what are the different cases that we can also merge with these agents. So like we are going to see how we can utilize dynamic few sorts with the agents and chains. We will be also seeing how we can create a custom agent in the Langchain, and so other different things like agent types and all. So yeah, thanks for making till the end of this video. Goodbye until the next time.